Question 12. An object is undergoing simple harmonic motion about a fixed point P. The magnitude of its displacement from P is x. Which of the following is correct? The magnitude of the resultant force and the direction of the resultant force. Well, we need to remember that our defining equation is this. It's minus omega squared x. So we know that it's proportional to x, and because of this minus, it's always in the opposite direction. And so let's have a look at this. So it's proportional to x is correct, towards p is correct. It's always towards. So if this is point P and you've got at a certain point x there, then your force is always in the other direction of x. That would be your forces, so it's always towards P. So 12A is correct. We don't need to worry about any of the others. That's straightforward. Looking at 13, an object undergoes simple harmonic motion, SHM. The total energy of the object is proportional to. Now let's just go here to our data booklet and pull up our formulas here. So we've got here our total energy. Is this over here? Our total energy m omega squared x 0 squared. So let's have a look and see with this which one would be the correct one. So it says the total energy of the object is proportional to the amplitude of the oscillation. Well, here we have the amplitude squared, the time period of the oscillation. Here we have our this is possible, but here remember omega is equal to 2 pi over t, or it's equal to 2 pi f. Remember that, we've got that, it's equal to 2 pi f. But here we've got an omega squared, so it will be proportional to the square of the frequency or the inverse square of the period. So the only one is the mass of the object. This would be correct. So it would be 13D would be correct, because we can see here that our total energy, we've got just a mass there, so that would be proportional to the mass. Question 14. What region of the electromagnetic spectrum includes the waves of a wavelength 5 times 10 to the negative 8 meters? Well, we know that our visible spectrum goes from about 600 nanometers to, I suppose, about 900 nanometers. You should really just check it up. Now, this over here, 5 times 10 to the negative 8, that is 50 nanometers. So this is a shorter wavelength. So this is a shorter wavelength, or the higher frequency. So it's on the towards the side of the lower frequency. So that would be your ultraviolet. Now the X-rays are extremely short wavelengths, or very high frequencies. So these would be much shorter than 50 nanometers. Both of the infrared and the microwaves are longer wavelengths, so those couldn't be. So only the ultraviolet really fits in this case over here. Going now to this question over here, question 15. We have a ray of light travels from a vacuum into glass as shown below. Now in a vacuum your refractive index is 1, so it's going from that. In glass, light has a speed v, in a vacuum has a speed c. Which of the following is a refractive index of glass? Now we're going to be using this formula over here, but obviously we'll be using n1 over n2 is equal to v2 over v1. Now if we have this n1 as our vacuum, it would be 1 over n2, which will be our refractive index of glass. So that would equal v2, that would be my v over c, and then I'd have to invert both sides, so I'd get my n of glass is equal to c over v. So A is going to be your correct answer there.